Something is dying, and it is closer than you think. High in the winter sky, resting on the shoulder of Orion the Hunter, sits a ticking time bomb of cosmic proportions. This is Betelgeuse. It is not just a star, it is a titan. If this red supergiant replaced our Sun, it would swallow Mercury, Venus, Earth, and Mars, reaching out to touch the orbit of Jupiter. It is so massive, so bloated, that it pulses like a dying heart against the black velvet of the void. Scientists are watching, breathless. Once a steady beacon, Betelgeuse has begun to flicker and dim, burning through its final reserves of fuel with a frantic, desperate energy. We are witnessing the final seconds of a million-year life. Somewhere in that swirling fire, the core is collapsing. The ground beneath us may feel still, but above, the greatest explosion in human history could be moments away. Before we start, like the video and subscribe to our channel, and let us know in the comments below where in the world you're watching from. We're always eager to hear where our viewers are tuning in from. Betelgeuse is a titan of the cosmos, a red supergiant that looms as one of the largest and most radiant stars visible to the naked eye. If you were to place it at the center of our solar system, its massive surface would extend far past the orbit of Mars, swallowing the asteroid belt and potentially reaching the neighborhood of Jupiter. It is a star in the final frantic stages of its life cycle, burning through its nuclear fuel at a rate that makes our Sun look like a flickering candle. Because it is so bloated and unstable, its brightness fluctuates constantly, causing it to pulse like a beating heart in the deep void of space. Locating this behemoth is remarkably simple, even for those who rarely look upward. It serves as the bright reddish-orange shoulder of Orion the Hunter, one of the most recognizable constellations in the Northern Hemisphere. You can find it sitting proudly in the upper left corner of the Hunter's torso, positioned just above the three perfectly aligned stars that make up Orion's belt. At roughly 550 light-years away, it is close enough to be a dominant fixture of our winter skies, yet distant enough that its inevitable destruction poses no physical threat to Earth. It hangs there as a glowing ember in the celestial dark, a massive ball of plasma that has reached its breaking point, waiting for the singular moment when gravity finally wins the war against light. To truly grasp the scale of Betelgeuse, you have to throw out everything you know about the size of our own solar system. If you replaced our Sun with this red supergiant, the results would be catastrophic and instantaneous. Our Sun is a respectable yellow dwarf star, about 864,000 miles across, but compared to Betelgeuse, it is a single grain of sand next to a beach ball. Betelgeuse is so massive that it would swallow Mercury, Venus, Earth, and Mars entirely. Its outer atmosphere would even stretch past the orbit of Jupiter, engulfing the largest planet in our neighborhood. This star belongs to a rare class of celestial titans. If you were to fly a commercial airplane around the circumference of our Sun, it would take you about 7 months. To complete that same trip around Betelgeuse, you would need to settle in for over 500 years of constant flight. While most stars we see in the night sky are roughly the size of our Sun or smaller, Betelgeuse is roughly 700 times wider. It is one of the largest stars visible to the naked eye, a glowing red behemoth that defies common sense. Its volume is so immense that you could fit over 1 billion of our suns inside of it. In the hierarchy of the cosmos, Betelgeuse is a monster hiding in plain sight within the constellation of Orion. Inside the heart of this colossal star, a desperate battle against gravity unfolds every single second. For millions of years, Betelgeuse fueled its existence by fusing hydrogen into helium, just like our own Sun does today. But a red supergiant is a different beast entirely. It burned through its initial fuel supply at a blistering pace, forcing the core to reach temperatures so extreme that it began fusing heavier and heavier elements. This process is the only thing preventing the star from collapsing under its own immense weight, as the outward pressure of nuclear fusion acts as a shield against the crushing force of gravity. As the star nears its inevitable end, the chemistry of its core shifts rapidly. Once the hydrogen is gone, it begins to fuse helium into carbon and oxygen. Eventually, the temperatures climb even higher. allowing the star to fuse neon, magnesium, and silicon. In these final stages, the timeline accelerates dramatically. While hydrogen burning lasted millions of years, the fusion of heavier elements might only last a few centuries, or in some cases just a few days. The final product of this cosmic assembly line is iron. This is the ultimate dead end. Fusing iron requires more energy than it releases, meaning the star can no longer generate the outward pressure needed to survive. The fire in the engine room finally dies out, leaving the core to wait for the final catastrophic moment when gravity wins the war once and for all. For millions of years, Betelgeuse maintained a perfect, delicate truce between two of the most powerful forces in the universe. On one side, the crushing weight of gravity pulls every atom inward, trying to collapse the star into a single point. On the other side, the intense heat generated by nuclear fusion in the core pushes outward with incredible strength. This balance, known as hydrostatic equilibrium, is what keeps a star stable. But for a red supergiant like Betelgeuse, the fuel lines are finally running dry. Deep within its heart, the star has already burned through its massive reserves of hydrogen and helium. To keep gravity at bay, it must fuse heavier and heavier elements, moving from carbon to neon, then oxygen, and finally silicon. Each stage happens faster than the last, producing less and less energy to prop up the star's outer layers. The outward pressure begins to falter as the core becomes caught in a losing battle. Eventually, the star attempts to fuse iron. This is the ultimate tipping point, because fusing iron consumes energy rather than releasing it. In an instant, the outward pressure that held the star together for eons simply vanishes. With nothing left to push back, gravity wins. The outer layers of the star, weighing millions of times more than Earth, suddenly plummet inward at a fraction of the speed of light, setting the stage for a catastrophic collapse. In late 2019, the world watched in confusion as Betelgeuse began to fade. It was not a subtle change. Over the course of just a few months, the great red giant lost 60% of its usual luster, becoming so dim that even casual observers could see the difference with the naked eye. Many wondered if this was the final warning sign before the star collapsed into a supernova. Astronomers pointed their most powerful telescopes at the constellation of Orion to solve the mystery of what became known as the Great Dimming. It turns out the star was not dying just yet, but it was behaving like a chaotic, heaving beast. Betelgeuse literally blew its top. A massive piece of the star's surface was ejected into space, a phenomenon known as a surface mass ejection. This gargantuan plume of hot stellar material was several hundred times larger than the typical events we see on our own sun. As this superheated gas traveled outward into the cold vacuum of space, it cooled down rapidly. This transition caused the gas to condense into a thick, concentrated cloud of stardust. This colossal dust veil acted like a dark curtain, physically blocking the light coming from the star's surface. From our perspective on Earth, it looked like the star was losing its fire, but it was actually just hiding behind a shadow of its own making while it struggled to regain its stability. In 2019, the Hubble Space Telescope witnessed something never before seen in the history of modern astronomy. Betelgeuse didn't just flicker, it literally blew its top. This wasn't a standard solar flare like we see on our own sun. Astronomers coined a new term for it, a surface mass ejection. The star blasted an unfathomable amount of its interior content into the void, reaching masses 400 billion times greater than a typical coronal mass ejection. This titanic eruption blew off a massive chunk of the star's visible surface, creating a colossal cloud of hot gas and dust that temporarily obscured the star's light from our perspective on Earth. When this happened, the star dimmed so significantly that many experts thought the final collapse had begun. Hubble's data revealed that this traumatic event left a literal hole in the star's atmosphere, leaving the gargantuan red supergiant vibrating like a gelatin mold hit with a hammer. High-speed imagery showed that the star is now struggling to regain its equilibrium as internal waves bounce back and forth through its distended body. This tells us that the internal structure of Betelgeuse is far more unstable than we previously imagined. The photosphere isn't just boiling, it is actively disintegrating. This massive loss of mass is a clear warning sign that the internal engine is misfiring, proving that the outer layers are losing their grip against the inevitable pull of gravity. Betelgeuse is not just sitting still, it is quite literally breathing. These rhythmic pulsations, known as the semi-regular variability of the star, cause the giant to expand and contract like a beating heart. For decades, astronomers observed these cycles occurring roughly every 400 days. During the expansion phase, the star cools and dims, and as it contracts, it heats up and brightens. This steady rhythm was the celestial heartbeat of Orion. But recently, that heartbeat has skipped a beat and moved into a frantic new tempo. Following the massive surface mass ejection, often called the Great Dimming, the internal dynamics of the star shifted dramatically. The pulsation rate has seemingly accelerated, with new cycles appearing twice as fast as the historical average. This happens because the star is struggling to regain its equilibrium after losing a significant chunk of its outer layers. Imagine a bell that has been struck so hard it begins to vibrate at a higher, more chaotic frequency. Experts believe this acceleration suggests that the fusion process deep within the core is moving into its final, most desperate stages. As Betelgeuse burns through heavier elements like carbon and neon, the energy release becomes more intense and less predictable. This creates internal pressure waves that push against the stellar surface more frequently. We are watching a cosmic engine redlining, pushing its structural limits as it nears the ultimate mechanical failure. When these pulses become too violent for the star to contain, it will no longer be able to hold itself together. Scientists have long looked at the heartbeat of Betelgeuse to predict its final moments. This massive star undergoes semi-regular cycles where it expands and contracts, a process known as pulsation. For decades, we observed a primary pulse lasting roughly 400 days. However, recent data has uncovered a secondary, much shorter pulsation period of about 200 days. This shift in rhythm is far more than just a cosmic quirk. It could be the smoking gun for an imminent collapse. When a red supergiant reaches the very end of its life, it begins fusing heavier elements like carbon and neon deep within its belly. This frantic burning creates intense pressure and heat, causing the outer layers to vibrate more rapidly. If the star is indeed pulsating at this faster rate because it has moved on to carbon burning, it means the core is shrinking, and the clock is ticking much faster than we originally anticipated. Some astrophysicists argue that this shorter cycle indicates the star has already reached its final evolutionary stage. If this is true, the delicate balance between outward pressure and the crushing force of gravity is nearly broken. Instead of having tens of thousands of years left, Betelgeuse might only have decades or even years. This accelerated heartbeat suggests the internal structure is losing its grip, potentially placing us on the literal doorstep of the most spectacular supernova in human history. When the iron core finally reaches its limit, the collapse happens with a speed that defies human comprehension. For millions of years, the star has been fighting gravity through nuclear fusion. But once the core is choked by iron, the engine stalls. Iron cannot be fused into anything heavier without consuming more energy than it releases, meaning the inward pressure of gravity finally wins the war. In less than a fraction of a second, an iron sphere roughly the size of the entire Earth crushes down into a ball no larger than a city. The speed of this collapse reaches nearly 1/4 the speed of light. Matter is cramped together so tightly that the very structure of atoms begins to break down. Protons and electrons are squeezed together with such ferocity that they turn into neutrons, releasing a phenomenal burst of ghostly particles called neutrinos. These neutrinos carry away more energy than the light of an entire galaxy. As the core reaches the density of an atomic nucleus, it becomes a solid wall of nuclear matter. The outer layers of the star, still racing inward at millions of miles per hour, slam into this immovable core and bounce. This creates a titanic shockwave that rips outward, tearing the star apart from the inside out. In this heartbeat of cosmic time, a red supergiant is transformed into the brightest object in the local universe. When the iron core finally collapses, it does so at a staggering fraction of the speed of light. In less than a second, an iron ball the size of Earth crushes down into a dense sphere of neutrons no larger than a city. This collapse happens so fast and becomes so incredibly dense that the inward-rushing outer layers of the star suddenly hit an immovable wall. Imagine a high-speed train slamming into a mountain. The kinetic energy has nowhere to go but out. This creates a colossal bounce, launching a supersonic shockwave back toward the surface of the star. However, this shockwave initially loses energy as it plows through the dense, infalling material. It almost stalls until a flood of nearly ghost-like particles called neutrinos pours out of the newborn neutron star. These neutrinos provide the final violent push needed to reignite the shockwave, turning it into a wall of pure energy. As the shockwave races outward, it tears through the star's atmospheric layers, heating the gas to millions of degrees and fusing new elements in its wake. When this front finally breaks through the surface of Betelgeuse, the star will instantly brighten to rival the light of the entire Milky Way galaxy. This radiant breakthrough marks the formal birth of a Type II supernova, sending a flash of light across the cosmos that will be visible from Earth even in the middle of the day. When Betelgeuse finally undergoes its core collapse, the resulting explosion will be a spectacle unlike anything human history has ever recorded. For weeks, the star will surge in luminosity until it rivals the brilliance of the full moon. This is not just a distant flicker in the night, it will be a piercing, constant light that casts distinct shadows on the ground after the sun sets. You would be able to read a book by the glow of this dying titan alone. But perhaps the most eerie and breathtaking part of this event is its visibility during the daylight hours. For about 2 months, Betelgeuse will be bright enough to hold its own against the blue of the sky. You will look up at high noon and see 2 bright objects, the sun and a sharp, brilliant point of light marking the site of a cosmic cataclysm. It will look like a shimmering jewel pinned to the heavens, visible to every person on Earth, regardless of their equipment or location. Eventually, the initial fire of the supernova will begin to fade. Over the course of several months, the intense glow will dim, turning from a brilliant white back to a deep, ghostly red, before finally vanishing from our sight forever. When it is over, the familiar shoulder of Orion will be gone, leaving behind a dark void where a giant once stood. When the iron core finally collapses and the shockwave tears through the stellar surface, our night sky will change forever. This will not be a fleeting flicker or a blink and you miss it event. The initial explosion will shine with the intensity of a full moon, concentrated into a single piercing point of light that will be clearly visible even during high noon. For 2 or 3 months, you could step outside in the middle of the day and see a second sun burning in the blue sky. As the weeks go by, the sheer brilliance will slowly begin to soften, transitioning from a blinding white to a ghostly orange, and eventually a deep, bruising crimson. Even after the initial fury subsides, the glowing embers of this cosmic cataclysm will remain visible to the naked eye for more than a year. Imagine looking up at the constellation Orion for 2 winters in a row and seeing a massive, unblinking eye staring back at you. Eventually, the light will fade below the threshold of human vision, leaving a hollow space where the hunter's shoulder once stood. Future generations will need telescopes to see the beautiful, expanding nebula left in its wake, but for those of us lucky enough to be alive when it happens, it will be the greatest show on Earth.